So yesterday we looked at section 2.4, which was on solving basically linear inequalities. Inequalities, when you graph them, they make straight lines. Okay, now we're going to look at higher order inequalities. Okay, inequalities that are quadratic, cubic. There's only ones we can do by hand using certain tricks. So if they get too complicated, we're just going to graph it. We're going to look at the picture. But basic ones, I'll show you how you can do by hand. All right, so we're going to start with this equation. Okay, I'm not sure if have we seen this before?
Yeah.
Projectile motion. Okay, so this models the path or the height of an object. And it's really dependent on two things. Okay. How long has the object been in the air after you throw it? Actually, three things. How long has the object been in the air? How fast was it thrown? And what was the initial height it was thrown at? Anytime you see a problem that says an object is thrown from ground level, that means the initial height is 0. If it says you're throwing an object off the top of a building, well, the height of the building would be the initial height. All right, so that says negative 16t squared plus v sub 0t plus s sub 0. Time is measured in seconds, and the height is measured in feet. Right, so that's all we need to really start, and we'll do our first example. Okay, for this one, it says a ball is thrown straight up from ground level. Okay, remember what I said that means. With an initial speed, or initial velocity of 80 feet per second. Okay, there's all kinds of things you can find out. How high does the ball go? How long is the ball going to be in the air for? Okay, but what we're going to try and find is, when is the ball 64 feet above the ground? Okay, so if you think about it, okay, let's say here's the ground. If you were to throw a ball, it reaches some maximum height and then it comes back down. Well, there's probably some point where it went above 64 feet. Okay, it stayed above there for a little while. And then there's another point where it comes back down below. So there's an interval. Between two certain times, the ball will be above 64 feet. All right, so we're going to try to graph it and see if we can figure that out. Okay, so I want to fill everything this problem is giving me into that equation. Okay, so my height equals negative 16t squared plus my initial velocity. How fast is the ball thrown here? 80 feet per second. And what's the initial height?
0.
0. Okay, initial height is 0. So in this problem, I don't need that. Okay, let's just graph that. So we've got negative 16. Remember, you have to use x on the calculator. X squared plus 80x. Okay, if you've got anything else in there, just get rid of that. And remember, when you graph something that's squared, it's a parabola, you're going to get that curved shape. Okay, it's going to look, the graph is going to look just like the path of the ball. All right, now I got to set my window. So what I'm going to do is I'm going to go to my table, and I'm just going to look at how high the ball is. Okay, at time 0, the ball's still on the ground. Haven't thrown it yet. After 1 second, it's up at 64 feet. Okay, 2 seconds, it's at 96. Well, 3 seconds, it's at 96. So something tells me between 2 and 3 seconds it hit its maximum, and now it's on its way back down. Okay, 4 seconds, now it's on its way back down. All right, so let's set our height maybe at 120 feet. If it goes higher than that, then we'll adjust for it. Does negative height make sense? No, unless the ball is going underground, which it's not. Okay, x is time. What should be my lowest value for time? 0. Yeah, 0. We're not traveling through time. We can't go backwards. So set your time at 0. And then the max is how long is the ball in the air for. We don't know. Let's assume it's not in the air more than 10 seconds. If it is, it'll go off the screen and we'll fix it. Actually, that's fine. Okay, so bless you. There's the path of our ball. Now, specifically, we want to know when this height is what? Equal to 64 or at least 64? So it could be equal or higher. So we want to know when this height, it's 80t, is greater than or equal to 64. Okay? So what I'm going to do, put a line in at 64. Now I can see exactly when it's above 64. What do I have to do at each of those points? What do I have to calculate?
Find the intersect value?
Yeah, I got to find the intersect. Okay. So this time the guess does matter. Okay, so I'll do the one on the left. Now where I put my guess is going to give me the one that I'm closer to. All right, so if somebody wants to find the intersect on the right, I can do the one on the left. 1 second. Okay, so 1 second after this ball leaves your hand, it's going to hit 64 feet. It's going to stay up above 64 feet until that other point right there.
So
4 seconds? 4 seconds. All right, so look, after 1 second, it's above 64 feet, 2 seconds, 3 seconds, and then 4 seconds. It comes back down to that point right there, and then goes back down. Okay, so that answers the question. The ball is above 64 feet between 1 and 4 seconds. It's exactly at 64 feet at 1 second and 4 seconds. Questions on that? Right. So same problem. Let's figure out how long the ball is in the air for. Okay, let me let's copy down what we had. Okay, to figure this out, let's see if we can factor it. What do both of these terms have in common? Yeah, you can take a t out. You could take a negative out if you wanted to. What else do they both have in common? Yeah, you can factor 16 out of both of them. Okay, so let's factor out a negative, a 16, and a t from both. If I factor out a negative 16 and a t, what does that leave me with here? Just one t. And if I factor a negative and a t out, okay, the only thing that's left is basically 80 divided by 16, which is how much? 5. Okay, you can always check it. Negative 16 times negative 16t times t, it's negative 16t squared. Negative 16t times negative 5, that's negative times negative is positive, 80t. Right? So we'll take a look at that in a second. So what does that really mean? How long is the ball in the air? Think about what that means in terms of the height. It's when the height is what? Yeah? It's when the height is above 0. All right? So we're going to look at when the height, negative 16t times t minus 5, that's our formula for the height. When is that above 0? Okay, if it's above 0, the ball's in the air. Okay. Now, this is kind of like the homework problem. We're multiplying two things together. We've got that, and we've got that. Okay, we're multiplying two things together, and we want to get something that's greater than 0. T is always what kind of number? T is always positive. always. Okay? Time is not negative. Time is always a positive number. 1, 2, 3, 4. What's going to happen to this box in green if I plug in a positive number for t? This green box is always going to come out negative. If time is 2, 2 times negative 16 is negative 32. If time is 3, 3 times negative 16 is negative 48. This green box always comes out negative. Nothing you can do about that. So what would this blue box have to come out to? The blue box would also have to somehow come out negative. That's the only way you're going to multiply two things together and get a positive. If this is negative and there's nothing you can do about it, this also has to somehow be negative. So that's the question we have to figure out. When is this box in blue negative? That will answer the question. Okay, so basically you're solving this. When is t minus 5 less than 0? How would I solve that? Karen?
You subtract,
Add 5. And that gives me t is less than 5. So how long is the ball in the air for?
5 seconds.
Less than 5 seconds.
Yeah, less than 5 seconds, like 4.9999 seconds. At 5 seconds, the ball hits the ground. So the ball is in the air for just under 5 seconds. And if you look at the graph, 1, 2, 3, 4, 5, you could calculate a root and figure it out that way too. Okay, but we didn't do that.
I was going to say, could you just put the original graph equation in and y at 0?
Yeah, anything you do algebraically, there's always a way you can do it graphically. Yep. All right, and we already did part B. I did that before we did this part. All right, so that method that we just used worked fine. Okay, worked fine as long as we can factor, which is what we did. We factored out a negative 16t. Okay, factoring is going to be how we deal with more complex inequalities. Okay, as complex as I'm going to get with you is quadratic. Okay, we're going to use what's called a sign pattern. Right, it's based on this idea. Every linear factor is 0 at exactly one value. In other words, if you draw a line, it would only cross the x-axis one time. That's what this means. Obviously, lines don't curve. So if you draw a line, it only crosses the x-axis one time. There's a line. Crosses right here. Okay, in one section of that line, everything is negative. Okay, in the other section, from this point on, everything is positive. Right? But there's this one value right here where it's 0. And there's only one value that makes it 0. Okay? That's what I'm saying. So for example, if this was a factor, t minus 1, okay, once we do some factoring, there's one number you could plug in for t that would make this 0. What number is it? Yeah, it's 1. It's kind of like this picture right here. Crosses the x-axis at 1. Okay, if this was a factor, t plus 4, there's only one number that you could plug in for t that would make this 0. Negative 4 plus 4 is 0. There's no other number. Okay, any question on that idea? That every line only crosses the x-axis one time. That's what that means. All right. So what we're going to do is after we have a problem we've factored, okay, we're going to draw our number line. Okay, on that number line, we're going to mark the zeros. We're going to mark the numbers that when you plug them in, they make it 0. So in this problem, we'd be putting a mark at 1, and we'd be putting a mark at negative 4. And what that's going to do is basically separate our number line into a negative section, okay, like in that blue part, and a positive section. Everything below that 0, if you plug it in, you'd get negative numbers. Okay? Try numbers smaller than 1 and plug them into t minus 1. Guarantee you always get negatives. Try 0, negative 2, negative 10. Try numbers bigger than 1. Okay? Plug in 2, 4, 5, 6. Okay? Plug in numbers bigger than 1, you'll always get positives. This is the number that separates the negatives from the positives in this factor. All right, so we have to determine where we're negative and where we're positive. Usually numbers to the left, smaller numbers than this, give you negatives. Try it in this one. Pick a number on the number line that's to the left of negative 4. Try like negative 6. Plug it into t plus 4, you'll get a negative. Take a number to the right of negative 4, like 0. Plug it in, you'll get a positive. All right, so we're going to determine where we're negative and where we're positive. Right, and we're going to do this for each individual factor. So we'll make a number line for this one, make a number line for that one. And then once we have a picture or a pattern for each of the individual terms, we're going to combine it together to get our final answer. Okay, it seems a little complicated, but once I show you a few examples, it's not that bad. Yeah?
Can you go back?
Yeah. Okay, page 113's got some more pictures if you want to see it, but we're going to do a couple examples together. Now, this whole method depends on being able to factor the problem I give you. If you can't factor, you can't use this. Okay, this only works if you can factor it. So I'm going to give you problems you can factor. Okay, everybody have what's on the left? All right, let's make that a little bigger. All right, 2x squared plus 9x minus 5 is greater than 0. Okay, first step to factor, draw two sets of parentheses. Right, now I got to figure out what times what is 2x squared. So I could use, 2x and x. I've got a positive middle, a negative constant. So what does that mean my signs have to be? Yep, I'm going to have plus and minus. It does matter which one we put where. So let's just try plus minus. And I need two numbers that multiply to give me 5. 1 and 5. And it does matter which one goes where. Let's try that. Okay, let's check, see if that works. So we get 2x squared. 2x times 5 is 10x. Take away 1x. Is that what we wanted in the middle? Yep. And a negative 1 times 5 is negative 5. Okay, so we factored it. These are both linear factors. If you were to graph that, makes a straight line. All right. First thing I want to do, figure out what value of x would make that 0. 1/2. Yep. 2 times 1/2 is 1. 1 take away 1 is 0. So we're going to mark 1/2. Right, now let's see what happens if we plug in numbers smaller than 1/2. Okay. Very easy number to work with, smaller than 1/2, 0. If I plug in 0, 2 times 0 is 0. 0 minus 1 is what? Negative 1. That means any number to the left of 1/2 is always going to come out negative when you plug it in. Okay, let's try a number bigger than 1/2. Let's try, we try 1. 2 times 1 is 1. 1 take away 1. 2 times 1 is 2. 2 take away 1 is 1. Comes out positive. Any number that you plug in to the right of 1/2 will come out positive. Okay, any question on that? Let's show you the hardest part about the sign chart. Find the 0, then determine negative, positive. Okay, let's do it for x plus 5.
So how do we find the 0?
One way you could do it is just take 2x minus 1, set it equal to 0, and solve it that way. Most of the time, they're going to be simple enough we can do in our head. What value for x would make that 0? negative 5. Okay, so I'm just going to mark that. If I plug in numbers smaller than negative 5, what would my answer be here? It would be negative. What if I plug in numbers bigger than negative 5? It would come out positive. Okay, and now we put those two number lines together for our final answer. Mark both of these spots. Negative 5, 1/2. So we have three regions we need to check. Less than negative 5, between negative 5.5, and greater than 1/2. Okay, if you want to mark the other zeros, you can. Like 1/2 might be somewhere over here. And negative 5 would be somewhere over there. Okay, let's look at what happens if we're less than negative 5 in both. What if you're less than negative 5 in the top one? What kind of numbers do you get? What if you're less than negative 5 in the bottom one? And what's a negative times a negative? It's a positive. Okay, let's look between negative 5.5 in both. Okay, top one. Between negative 5.5, what kind of numbers? Negative. Okay, between negative 5.5 and the bottom one? Positive. What's a negative times a positive? Negative. And then let's look at what happens when we're bigger than 1/2. Top one, bigger than 1/2? Positive. Bottom one, bigger than 1/2? Positive times positive? Positive. Okay, one thing that always happens in the final answer, these regions always alternate. So really, once you find the first one, as long as you found it correctly, just alternate positive, negative, all the way down. And now this is going to tell us our final answer. They want to know where we are greater than 0. What's going to happen there and there. In here, in the middle, it's not going to happen. You're going to get negative numbers. That's not greater than 0. Right? So the way we could write this as an interval, we could pick any number from negative 5 all the way down to negative infinity. Whether or not I include negative 5 depends if we had a bracket, an equal to or not an equal to. There's no equal to. So I'm just going to put a parenthesis. So any number from negative infinity up to negative 5. Or I can pick any number from 1/2 up to positive infinity. Okay, as an inequality, it would look like this. X is less than negative 5, or x is greater than 1/2. Okay, I would make sure you're comfortable writing it both ways, inequality or as an interval. Questions on that? It's, we've got two more. We don't have to do both. We can just try. Let's just try this one. Okay, this time we have 3 factors. If something's going to factor into 3 things, I probably wouldn't make you factor it. I would factor it for you. Right? And we got to find what would make each one 0. Okay. What would you plug into this first one to make x 0? It's got to be a number. I think a lot of people said it. 0. Yeah. What would you plug in to make the second factor 0? And the third factor? 1. Okay, if you plug in numbers smaller than 0, what kind of numbers do you get? Those are your negatives. If you plug in numbers bigger than 0, you get positive. Okay. If you plug in numbers smaller than negative 3, you would get what? Negative. How about numbers bigger than negative 3? Positive. Okay, really, it's negative is on the left, positive is on the right.
All the time?
Yep, all the time, unless I gave you one like this, which would switch everything. But I'm not going to give you one like that. Okay. All right, now put it all together for our final answer. Okay, we're going to mark all 3 of these spots. We've got negative 3, 0, positive 1. So we have 4 regions we need to check. And what's the trick I said? What's going to happen in these regions? It's going to alternate. We'll check the first 2 just to make sure we're good. But then it's just going to alternate negative, positive, or other way around. All right, let's check less than negative 3 on all 3 number lines. In the top one, if I'm less than negative 3, what's the sign? Okay, I'm just going to write that down so I don't forget. In the middle one, less than negative 3? Negative. And in the bottom one, less than negative 3? Negative. What's a negative times a negative times a negative? Negative. So the next one should be positive. All right. Top one, between negative 3 and 0.
Negative.
Yep, we're in the negative. Okay, middle one, between negative 3 and 0.
Negative.
Positive. Okay, everyone see that one? 0 would be right about there. That's between negative 3 and 0. Right? Bottom one, between negative 3 and 0.
Negative.
Negative. What's a negative times a positive times a negative?
Positive.
That's a positive. All right, and this one, the question was, where are we positive? Where are we greater than or equal to 0? Here and here. Okay, so my first interval, and this time I can include it because we have the equal to's in this problem. So from negative 3 to 0. What kind of interval is that when you got a number on each end?
Bounded.
That's bounded. Okay, so a bounded interval from negative 3 to 0. Or, how would I write this interval?
1 to the infinity.
1 to infinity. Can you tell me my symbol on each end? Parenthesis.
bracket.
Parenthesis where?
On the 1.
Not a parenthesis on the 1 this time. Parenthesis on infinity. Why do I put a bracket on 1?
So that means you can do
Because what?
It's not including.
1 is not including or it is including?
It's including 1 and 2.
Yeah, we're including the 1. Okay, that's why we put the bracket. Anytime you have equal to, you put the bracket. Infinity always gets a parenthesis though because you can't reach it. Okay, any question on that one? Okay. Division works the same way. The top one would have a 0 at 4. The bottom one would be negative 2.5. And we do the same thing. Does anyone need me to go through this one? We'll take a quick look. All right. So mark your 0, negative 4, negative 2.5. To the left of negative 4, that's negative. To the right is positive, negative, positive. Positive 4. Thank you. Is that what you're going to say?
Yeah.
Yeah. Positive 4, take away 4 is 0. All right. Make my final number line. Mark negative 2.5. Mark positive 4. 3 regions to check, and they should alternate. Okay. In the top one, what if I'm smaller than negative 2.5? Negative. And in the bottom one? Negative. Okay. Paige, what's a negative divided by negative?
Positive.
Positive. Okay. I like to just check one more region. I know the answer should be negative, but let's just check. Between negative 2.5 and 4. What am I? I'm negative. In the bottom one, between negative 2.5 and 4. Positive. What's a negative divided by a positive? Negative. Okay. Now in this one, they wanted to know, where am I negative? Where am I less than or equal to 0? Just right there. Okay. And it's said equal to, so it's a bounded interval. from negative 2.5 to 4. All right, so this method works fine as long as you can graph it. But if you can't graph it, you can't use a sign chart. I'm sorry, factor it, not graph it. If you can't factor it, you can't use a sign chart. So in that case, we'll just graph it. Okay, we'll look at a picture. It doesn't matter how complicated it looks. All we got to do is type it in and let the calculator do all the work. All right. So what I'm going to do is put everything on the left in y1. So we got x cubed minus 2x squared minus 5x plus 7. And then in y2, put what's on the other side, 2x plus 1. And I want to know where what's on the left is above or equal to what's on the right. In other words, where is the blue line above the red line? Okay, so where is the blue above the red? There's the blue. There's the red. Let's take a look at that. Okay, where is the blue above the red? Well, I've got some intersections. I'm going to have to find all of these. Okay, the blue is above the red. Okay, in that spot. Not in this next spot, it's below, and then in this spot. So there's two sections where blue is above red. Here and here. Any questions on that? Now I'm just going to have to find these intersection points. Okay. Does anyone need me to go through and actually find them? Okay with that? Let's just call them A, B, and C. So describe to me, where is the blue above the red? Between A and B, and it's a closed interval. Remember, these would be the x values of the intersects. So between A and B. And where else is the blue above the red? Yeah?
From C on.
From C on forever. So just find all the intersects. Look at the x values. That's what A, B, and C are. All right, so for more complicated graphs, you just do it that way. Right, any questions on that one? So last thing we'll do, we'll start 3.1. I'm not sure how much we'll get through, but we'll see what we do. And whatever we don't, we'll finish tomorrow. All right, so that last section, that finished chapter 2. Okay, so that's on inequalities, and we're done with those. Chapter 3 starts out by looking at graphing. And basically, when we look at a graph, before we even type it in, how we can figure out how many twists and turns it's going to take. Yeah, you can. I think I mentioned it. Hang on to that thought. But yep, there's a way you can tell how many turns it might take, how many times it could cross the x-axis, stuff like that. Right, so that's what a polynomial looks like. Okay, in general form. Okay, so you could have something like 3x squared plus 2. Or like 3x to the 4th plus 2x cubed minus 8x plus 6. Okay? You'd have a lot of numbers for all these terms. Okay? In a polynomial, all the exponents have to be non-negative integers. Okay? All the exponents have to be nice numbers. This is not a polynomial. Can't raise something to the 4.2 power and have it be a polynomial. Okay. All the coefficients have to be real numbers. So you can't have some imaginaries like this. 2 plus I times x squared. That's not a polynomial. That's imaginary. All right? You're going to have real numbers. You can have decimals in front. You just can't have decimals for the exponents. Okay. And as long as your first coefficient is not 0, this number will tell you the degree of the polynomial. Okay, it's the highest exponent. Now, if they did something like this, this would be a little tricky. What's the degree of this? 3. Okay, it's not 4 because this first term doesn't even exist. You're multiplying it by 0. It's not even really there. So as long as that first term isn't 0, the highest exponent is the degree of the polynomial. Question? What's up? Question? Question for me?
Yeah, what's going on right now?
We're just talking about what a polynomial is.
And what's up with the n and the minus 1 and
So this is the general form of a polynomial. Your exponents always go down by 1. Like 3x cubed, 2x squared. Squared is 1 less than cubed.
okay, now it makes sense.
Just goes down. So again, these will all be numbers. This last number would just be like 5, constant. And I don't know how big of a polynomial you're going to have. Some polynomials are longer than others. So that's why I put dot, dot, dot.
What is that symbol with the e next to the real number?
Oh, this just means all these coefficients in front are real numbers.
Oh.
A sub n is a real number. Just a shorter way to write that. This is the symbol for real numbers. Okay, sometimes when we have a polynomial, we give it a special name depending on the degree. Does anybody know what degree 1 is? When you draw it, think of what it makes.
Line.
A line, call it linear. How about degree 2?
Parabola.
It's a parabola, but what kind of equation is it called? It's a quadratic. And degree 3? That's a cubic. And those are pretty much the only ones we use special names for commonly. Degree 4 you can call quartic, but usually we just say it's a polynomial degree 4. Okay? Or polynomial degree 7, degree 8. But these are the common names we use. Sarah, question?
I just wanted to double check them. Exponents can't be negative, right?
Exponents cannot be negative. Nope. Not with a polynomial. Okay. The nice thing about a polynomial is the domain for every single problem is all real numbers. Okay. Reason, if you take a polynomial, I'm just going to make one up. In a polynomial, all you're doing with a number is plugging it in and raising it to a power. You can raise any number you want, any real number, to any positive power all the time. Okay? There's no number that you're not allowed to square. There's no number that you're not allowed to cube. There's no number you're not allowed to multiply by 4 and then subtract 2 from. You can do that to any number you want. So the domain is all real numbers, but the range depends. Okay, think of a parabola. In that case, the range has a low value, and it goes up forever from that lowest point. Okay, but if you were to draw a line goes up and down forever. A line doesn't have a minimum value. It just keeps going. Just keeps going down. So the range depends. Okay, we have to graph it and take a look at it. Yeah?
So the range would be the y?
Yeah, the range is how high and low it goes. And the domain is the x, which the domain is always all real numbers. Okay. Cubic functions generally look something like this. We have like 4x cubed plus 8x squared minus 2x plus 1. Okay, A, B, C, and D, those are all numbers. Okay, and a cubic function can turn up to 2 times. Okay, so to figure out how many times a polynomial turns, look at the highest exponent. If you subtract 1 from it, that's how many turns it can take. So this one takes a turn right here, and another turn right there. Okay, again, that's just how many turns it can take. These first two, it kind of thinks about turning, but then it's like, nope, I'm not going to turn. Just keep going. So 2 is the most number of turns it could take. Okay, how about a 4th degree polynomial? How many turns could that take up to?
3.
Up to 3. So you could get kind of a W shape. Okay, same basic behavior as a parabola, though. One end, in this case, the left end goes up forever. The right end goes up forever. But it does a little turn in the middle. But overall, if you zoomed out on this picture enough, it would look something like this. It basically would look like a parabola. There's just a little turn in the middle of it. All right, so this one, let's just graph it and see if we can find the domain and range. Okay, so it's x to the 4th plus 5x cubed plus 2x squared minus 8x plus 1. Squared minus 8x plus 1. All right, this is a 4th degree polynomial, so it could have this W shape to it. Let's take a look. Yep, it's got that basic W shape. I can't see where the bottom is turning. So what I'm going to do is set my y min a little lower. Okay, try negative 20. Yep, and that's good. All right, so what's the domain of that function? What values am I allowed to plug in for x? All real numbers. Okay, you shouldn't even think about that when I ask you the domain of a polynomial. It's always all real numbers. So domain is all real numbers. And range. Does this graph go down forever and up
Oh,
forever?
I forgot. I know.
Yeah, it does go up forever. It doesn't go down forever. In fact, the lowest it ever hits is about right there. Okay? So what we can do is find that minimum value. Okay? So go second calc 3. Okay, find the minimum. And the y value is what we're looking for. That's the range. Remember, y value is range. So the lowest this function ever goes is about negative 11.9. And then it goes up forever. So the range is all numbers greater than or equal to that one, negative 11.9.
Can you be like 12 or no?
What's that?
Can you be like 12 or no?
I would round properly,
Okay.
usually to 1 decimal place. Yeah, that's fine. Okay. Any question on that? All right. So 5th degree polynomials, I'm not going to draw them out. You can look at them on 136 or page 143. But 5th degree ones can turn 4 times. So here's just one example. 1, 2, 3, 4 turns. Okay. We're not going to spend a lot of time working with 5th degree ones. They start to get too complicated. Yeah, what's up?
Oh, no.
Right. This graph right here and this graph right here have what we call local minimums and maximums. Okay. Basically, a local maximum is a point that's higher than everything else around it. I'm not saying this is the highest point in the entire function, because this goes up forever. But it is the highest point in this small area. Okay? So that's called a local maximum. It's a point that's higher than everything else around it. And this is a local minimum. It's a point that's lower than everything else around it. Okay? I'm not saying that it's the lowest point in the function, because it goes down forever. But it is the lowest point in that area. Okay, so anytime a function turns, you get a local min or a local max. Now, sometimes it could be a global minimum. That's a global minimum, right there. That's the lowest point the function ever hits. It never gets any lower than that. So a parabola has a global minimum. Okay? A function like this does not. It goes down forever, it goes up forever. Okay? Here there's a bunch of local mins and maxes. But they're all local because it goes down forever and up forever. Okay, it's a local min. That's a point that's lower than all other points around it. Okay, together, if they ask you to find the local extrema of a graph, they want you to find all the local mins and maxes. There's no algebra you need to do that. All you do is use the calculator and do second calc minimum or maximum. And that's it. Right, so let me just show you, I'll do one quick example of how you find a local min. Okay, I'll just graph x cubed minus 4x. Just watch me do this. You don't have to go through it if you don't want to. X cubed minus 4x. Okay, there's a local min and a local max. To save time, I'm just going to do one of them. I'll do the minimum. The minimum is on the right-hand side. So pick a point left, pick a point right, and take a guess. Okay, so the local minimum is negative 3.08. The minimum, that's the y value. Where it occurs, that's the x value. Where, when x is 1.15, that gives me y, which is negative 3.07. So that's important. Where it occurs is the x value. What it actually is the y value.
Is the maximum the y value group?
Yep, maximum's the same thing. Yep, I'm not going to go through the max, but the max will be the y value. And then where it occurs is the x value. In fact, I think the max is the same numbers. I think it's negative 1.15, positive 3.08. Just change the signs. And this will be our last thing. So once we find a min or a max, that basically can tell us where the function goes from increasing to decreasing. So where is this one increasing? Between which two letters?
B and C.
Yeah, between B and C. Where is it decreasing?
Between A and B and C and D.
Yep, between A and B and C and D. Okay, so as a function goes from increasing to decreasing, look what happens. Increasing, decreasing. What do you call that point right there? as a function goes from increasing to decreasing. That's a local max. Okay, so when a function goes from increasing to decreasing, you get some kind of maximum. How about as it goes from decreasing to increasing? What do you get right there? Oh, Will? As it goes from decreasing to increasing. What happens right there? Well, this was a local max, right?
Yeah.
What's this? That's a local min. Okay, so as a function goes from decreasing to increasing, you get a minimum. So on the homework, if they ask you to find where a function is increasing or decreasing, you need to find the maxes and mins. Okay? All right, so the homework, it's on page 116. Okay, there's about 10 or 11 questions on each page. Okay, so page 116 is the first page, and then 149 is the second page. Okay, we'll look at that tomorrow, and then we'll go over any questions. And we'll finish up everything for the test tomorrow. Okay, there's only one section left.